Okay, simplifying radicals. Simplifying radicals is a topic that kind of stems off what we did with difference of squares. Okay, now think about the word your perfect square. We've already talked about it. How do you create a perfect square, or what is a perfect square? Thank you for reading the definition. No, think about a square. Let's think back, because you guys, other than reading the definition, you need to know exactly what we're talking about. I feel like whenever we read the definition, you guys are like, okay, I read the definition, I can repeat that back, but that doesn't really help. Think about a square. Think about the characteristics of a square. What do you know about all the sides of a square? They're all equal. They're all the same. So if the length or the base and the height of a square is the number 3, how do you find the area? 3 times 3. 3 times 3 is the same as what? 3 squared, right? And what is 3 times 3? 9. So the number 9 is a perfect square, because what do you do to undo a square? You take the square root. Remember, we talked about that. You take the square root. When you take the square root, you end up with a perfect whole number. All right, what about 4 times 4? Let's say the sides of our square are 4. 4 times 4 is 16. 16 is considered a perfect square. What about 6 times 6? 36 is considered a perfect square, because you get it from multiplying the same exact whole number times itself. Now, this also applies to variables. We're not going to work with variables today, but since we have covered that, let's go back over it. What if I take the variable x? How do we get from x to x squared? X times x. But how do I undo that square? You take the square root of it. And when you take the root of it, you end up back where you started, with x, a whole number x, in this case, a whole variable x. Okay. So we're good. That's what we're going to be working with. Everybody got that? Now you are going to need this list of your perfect squares. We're going to be working with these numbers only. So just highlight straight down right there. All of the numbers that are under the root. All of the numbers that are under the root, and turn the page whenever you are ready, or flip it over. When we are finding our perfect squares, finding the factors of these numbers is part of the process. So let's go back over that. We've been finding the factors of numbers using the calculator for several weeks now. How do you find the factor of any number? What is a factor? What is a factor? If I ask you for the factors of 18, if I ask you for the factors of 27, the multiples, what numbers do you multiply to get those numbers? Now, how do we find those if we don't know them off the top of our head? Use the calculator. Where do you go to? Okay, so let's write the steps down again. Go to y equals. Now, y equals is a button, so I'm just going to box it in. What do you do in the y equals screen? The number divided by x. Where do you put that? Into y1. You don't type y1 in because the first line is y1. Let me zoom in. Sorry about that. There you go. You type that into y1, the number, whatever number you're looking for, divided by x. Now, do we have to have x plus y1 in the second line? No, because that is only used whenever we do diamonds. Okay. Now, after you type the number divided by x, where do we go? We got to find the table, and we find the table by pressing second. That's a button, graph. Okay, second graph. Now we're looking at the table. Which numbers can we pick from? Only which ones? Correct, only the ones without the decimal, only whole numbers. You can only pick from the whole numbers, only whole numbers. Now, another part of this topic that we have to cover is being able to type these numbers under the root symbol. How do you find the root symbol? It's right above what button? X squared. So since it's in blue, what do you have to type? Second x squared. Second x squared. Because if you guys come to me and say, I don't know how to find the root symbol, we're going to come back to these notes. And if you don't have these notes, guess what? Ms. Ramirez is not going to feel sorry for you. We're literally writing all the buttons you have to push. All right. So let's start reducing. Let's start simplifying these radicals. Type in the square root of 1. What do you get? Let me detach my LCD. There we go. Oh, clear. Second square root 1. And it gives you 1. It gives me a whole number. That must mean that 1 is considered a perfect square. 1 times 1 is 1. What about the square root of 4? 2 times 2 is 4. So 4 is a perfect square. They give you whole numbers. Some of them are that easy. On your assignment, you're not going to have any perfect squares, by the way. Ready? All right. What happens if you type in the square root of 18? What decimal? 4.24, because 18 is not a perfect square. 18 is not on this list. Notice how my perfect squares jump from 9, from 3 times 3, up to 16, 4 times 4, and then 25. So we skip over 18. It's going to give us a decimal, so we have to reduce or simplify it. Now we do that by finding the factors. So let's find the factors of 18. I'm going to create my table, just like we did with greatest common factor. And what are my factors of 18? 1 times 18, 2 times, and 3 times 6, okay? Now for the hard part. You're going to take this list that you've created and compare it to the one that you highlighted, which is why I left it here side by side. That way you don't have to keep flipping back and forth. And you're going to highlight all of your perfect squares. Now the number 1 will always be a perfect square. So let's go ahead and highlight that. And I'm not going to ask about each number every time, but I am right now. So let's compare. Is 18 on this list that we highlighted? No, because it jumps from 16 to 25. What about the number 2? No, most people see this number 2 over here, but we're actually talking about the square root of 4. That's a perfect square. So no, 2 is not a perfect square. If you put the square root of 2 in the calculator, it'll give you a decimal. What about 9? 9 is on that list right here. Square root of 9 gives you a whole number. What about 3 and 6? No. So we are, which number do you think we're going to pick from? We're always going to pick the largest perfect square, but when we write it, we want to pick we want to write the highlighted one in the front, okay? So let's write ourselves a little note. We're going to pick these two. And this isn't one of those where we were going to circle and underline. We're going to pick this one. Okay. Pick largest perfect square. You're always going to pick your largest perfect square. So in this topic, it's very, very important that you write all of the factors, not just some of them, okay? You want to pick the largest perfect square. Now we're going to break this number apart under the square root. So when we break it apart, and you also want to write the highlighted one in the front. Always put the highlighted one in the front. So I'm going to write it as the square root of 9 times the square root of 2, because 9 times 2 gives us 18. Okay. I'm going to write myself a little note to the side. Highlighted one goes in the front. I hope you're having a good nap over there. Highlighted one in the front. Great nap. Got my jams on, head nodding back and forth. Yeah. Highlighted one in the front. All right, now let's reduce it. What is the square root of 9? The square root of 9 equals 3. You could type it in the calculator or you can look at your list. So the square root of 9 is 3. Once again, if I type the square root of 2 in the calculator, it will give me a decimal. So you just bring it down. Takes longer to write the steps than it actually does to do the problem. So after this, it should be pretty much downhill. Oh Lord. Okay. Everybody got that? All right. Square root of, let's move on to the next one. I'm just gonna go down the list. What is the square root of 144? If you type that in the calculator, what does it give you? Does it give you a decimal? All right. Okay. It gives you 12. So since we get a whole number as the answer, that must mean that 144 is considered a perfect square. Now that's the only other perfect square in this whole thing. So we're going to be finding the factors of all of these numbers. Ready? This is going to be fun. Don't worry. Ready? All right. Got it? Okay. 60. If you type in the square root of 60, it will give you a decimal. So let's continue and let's go ahead and find the factors of 60. All right. Now don't speed through it because I write slow. 1 times. All right. 2 times. 3 times. 20. There's 6 of these. 4 times. 5 times. All right. 6 times 10. Okay. Now you want to compare every single number, not just the ones on the left or not just the ones on the right, because I did have that question earlier. Compare all the numbers. I'll start. Always the number 1. You can always highlight the number 1. Does anybody see any other perfect square? All right, let's do it this way. Is 60 on the list? No, because we jumped from 49 to 64. Everybody see that? What about 2? 30? No, we jumped from 25 to 36. You see that? What about 3? 20? Nope, 16 to 25. Skip right over 20. What about 4? Yes, 4, you see it right here, right under the square root. So 4 is a perfect square. 15? No, we have 16 on the list, but not 15. 5, 12, 6, 10. No, so we found all of them. Now, which one are we going to use? 4 and 15. And which one do we put in the front? The 4. You want to put you want to pick the biggest highlighted number, but you want to write the highlighted one in the front. Okay, so square root of 4, square root of 15. And the square root of 4 is 2, equals 2. Now, since the square root of 15 doesn't exist over here, you bring that one down, square root of 15. Got it? Okay, moving on. Find, okay. Okay, factors of 98. There's only 3 sets of numbers. So factors of 98, 1 times 98, almost done. 2. Yep, 2 times 49. 1 more. 7 times 14. Okay. Which ones are my perfect squares? I'll pick 1, 2. Are you sure? It's not 2, but it is what? Which one is? You see 49 right here? Okay. So 1 and 49 are both on that list. So which one are we going to pick? The 49. Making sure that the highlighted number, the 49, is in the front when we break it apart. So root 49 times the square root of 2. What is the square root of 49? 7. 7 root 2. Questions? All right. Yep, that's as small as it'll get. What's up? Yep. Yes, ma'am. It will appear like that on the benchmark. All right. She said, I can't do this. Okay. Factors of 50, 1 times. Five times 10. All right. I know that the number 1 is a perfect squared, but what other one? 25. And which one are we going to pick? 25. Okay. Now, which one's going to go in the front? 25. Now, I've had people think that the biggest number always goes in the front, but that's not always the case, okay? The highlighted number goes in the front. So what's the square root of 25? 5. 5 root 2. What? Why is this 5 root? Oh, why is it designed like that? I cannot answer you. I cannot answer that question. I don't know why they designed the root symbol that way. But are you done copying this one? Yes? I mean, I guess you can be curious about that, but I still don't know the answer. All right. 8. What are my factors of 8? 1 times, 2 times, and what are my perfect squares? 1 and 4, with the biggest one being 4. And which one am I going to write in the front? 4. Root 4 times square root of 2, and the square root of 4 is 2, correct? I'm sorry, what? Okay. I don't know. Because he just wants to get over with notes. Everybody got this? Serious? Okay, square root of 27. Let's find the factors of 27. 1 times. Okay, so what are my perfect squares? 1 and 9. And we're going to pick the 9. Okay. Which one do we write in the front? The 9. So square root of 9 times the square root of 3. What is the square root of 9? 3. So 3 square roots of 3. Ready? Factors of 20. 1 times 20, 2 times 10, 4 times 5. Okay. So I know 1 is a perfect square. 4 is a perfect square. Somebody's getting anxious. And which one do we pick? 4. Come on now. I know you want your friends at home watching this to learn. Which one do we put in the front? Square root of 4 times the square root of 5. Now the square root of 4 is 2, and bring down the square roots of 5, the square root of 5. Good. Yes. But they don't hear you all the time. So that's why I repeat what you say. You got it? All right. Factors of 32, 1 times, 2 times, 4 times 8. Okay. 1 and there you go, 16. 16 is also a perfect square. Most people recognize the 4 and then they stick with the 4, not realizing that you also have the square root of 16. It's very important that you pick the biggest root because we put the 16 in the front. Because if you don't, if you had to pick the 4, the 8 breaks down again. So what is the square root of 16?
It's 4, it's not 8.
4 times 4 is 16. Don't worry. That's been said every single class period. Everybody always says 8, but it's not 8 plus 8. 8 times 8 is 64. 4 times 4 is 16. Got it, everybody? All right. And the factors of 76. 1 times, 2 times, and 4 times. Good. What are my perfect squares? And we pick the last one's going to have a bunch of them, so I'm ready. So we're going to put square root of 4 times square root of 19. Square root of 4 is 2. Bring down square root of 19. Got it? Okay. Last one. This one has 10 different sets of factors. 432. Hold on. What? 1 times 432. Hold on. Okay.
3 times 144.
Okay.
4 times 108.
Okay.
6 times 72.
Okay.
8 times 62.
Okay.
9 times 48.
Okay.
12 times 36.
Okay.
16 times 26.
Okay.
18 times 24.
All right. I do not want Hagen or Hillary to participate for this next part. So Dana, give me one of the perfect squares for this. Okay. Ale, give me another one. Okay. Emmanuel, give me another one. 1, okay. Angel, give me another one.
16.
Ooh. Zai, give me another one. Ooh. Enrique, give me another one. I know because you fell asleep. Malia, give me the other one. All right, and the biggest one is? 144. So we want to put the square root of 144 in the front and root 3 in the back. What is the square root of 144? So 12 root 3. Okay, go ahead and glue this into 103.